Welcome. Welcome to the reveal of Project March, the Exoskeleton, March 2. Welcome partners, friends, family. Also team members from the old team of Project March and team members of the new team of Project March. Also people who are following us via the live stream. Today, on the 31st of August, we will share the end result with you of the Exoskeleton, the year of work of 31 students. We are just 100 meters away from the place where the Exoskeleton was built and designed. But why? Why was this project started? This was due to the fact that a few people had to find a new and better way, a better solution for someone in a wheelchair, someone with a spinal cord injury. Someone with paralyzed legs is now currently bound to a wheelchair for the rest of his life. And Project March wants to change this. Project March wants to give back full mobility to paraplegics, to let them participate in daily life activities in a natural way again. And we want to make this vision a reality. And we do this by developing an exoskeleton and always improving this technology. The last time I saw you was probably during the design presentation a few months ago. We gave that presentation in the auditorium of the Delft University of Technology. During this presentation, we revealed the design to over 500 people. The design has changed a bit since last time. The last 5 months, we worked really hard to realize a working exoskeleton. And to prove that we have an applicable exoskeleton, we will compete in the Cyberlon experience. During this competition, we have to overcome 4 different obstacles, which are standing up from the sofa, the rough terrain, slopes and door, and as last, the stairs. These obstacles are daily life challenges for someone in a wheelchair. Some of them are almost impossible to do in a wheelchair. And by participating in this competition, we would like to give a boost to the technology which is used to develop these exoskeleton. And besides us, there are also participating commercial teams, academic teams, and also research teams. And all of us together, we hope to participate in this Cyberlon experience, and we can exchange knowledge and to create even more of these awesome machines. In the upcoming 25 minutes, I will give you an insight in the year we have been through. In the year of the second team of Project March, where 31 students worked 1 year voluntarily into this incredible project. And building an exoskeleton is not one of the easiest things to do, because it takes 31 students and 1 year time to build a whole exoskeleton. And these students didn't have much practical knowledge in the beginning of the year. And during our year, we faced some different challenges, actually. And I want to talk you through 4 different challenges which we faced during our year, which was communication, time, learning new things, and finding the right expertise. First of all, the communication. Since we were a team of 31 people, and the exoskeleton is a really multidisciplinary project with a lot of interfaces. So to have a good collaboration, you will need a lot of communication lines. And in this picture, you see us having a meeting, our monthly meeting, with a lot of people and taking decisions. Decisions takes always longer than planned. And as you can see, sometimes we continue in the evening. You can see it's already dark outside. But we hope if you make a lot of nice decisions, good decisions, that it will save you time later on. And talking about time, this brings me to the second challenge we faced. Building an exoskeleton in 1 year time. Our strategy was that we will do a lot of work in advance so that we can save up time later. And as you can see, we made our planning in the beginning of the year, and every department of us had its own colored stickies. We were very famous in the Dream Hall by the means of our stickies, actually. And in February, we didn't have much tangible parts, actually. We just started roughly designing parts in our 3D software. And until June, there were still no assembled parts in our workshop. And actually, the funny part of our story from our planning is that we just assembled the whole exoskeleton in less than 3 weeks. Compared to a year, that's relatively short in my eyes. And this brings me to the third challenge we faced. This was trying out new things. We didn't have any lectures anymore because we were joining a year of Project March. And the first questions we had to ask ourselves when we started is, what kind of exoskeleton are we going to make? Are we going to make a really simple one? Or one that is more extended with extra features? How complex are we going to make it? And what is actually achievable in 1 year time? The things that we knew for sure was we want to make a new transmission. We want to make a new human gait, the walking pattern of the exoskeleton. We had to make our own custom electronics, had to create safe batteries for the exoskeleton, and also design the fixtures, the way of how the pilot is attached to the exoskeleton by a combination of metal and straps. But these things were all related to the exoskeleton. But these were not the only things we had to do for the first time. This morning, we organized a press moment. And therefore, we had to do a lot of press writing. And we had to create some content for the project and awareness, such as a press release. We also had to organize an event for over 500 people, the design presentation, including Martin van Rijn, the State Secretary of Health and Well-being. And we had to set up an extended sponsor contract as well for our partners. And as last but not least, we had to write a lot of Facebook posts, which is actually harder than you would think. And the limit of time also compares to the experience we have with designing parts for production and assembly and finding the right expertise. Because we are students from the Delft University, almost everybody, but we didn't have all the practical knowledge, and therefore we had to find help by looking for companies who are willing to support our incredible project. And as a team together, we find all the expertise we need and finish the budget. So I would like to thank all our partners who are willing to support this project and who helped us with finding all the expertise which we need. But don't forget why we're here today, because this is time that we will reveal the exoskeleton. Maybe you have seen some footage of the exoskeleton today already, because the press moment was here in the morning. But are you guys as excited as I am? I will no longer keep you waiting. So sit back, grab your cameras, and enjoy. Wow, Ruben, we have to mute this song for a second. Perfect timing, thank you. Wow, Ruben, just incredible walking over here. What do you feel? How is it feeling? What does it walk?
I would take a bow if I could. Difficult from here. It feels incredible. It feels very secure, very tight to my body. It's amazing what the students achieved in this short time. I'm very proud of all.
Thank you, thank you. And what do you think of the last trainings that we had and all the challenges we have been through? Because we have loved a lot together, right?
Yeah, we did. We had some setbacks, but most of all, there was a lot of positivity in the whole team, and that, we laughed a lot, what Donald said, and it feels great to be a part of the team. And the last few training sessions were good. There were some bad things, some good things, but overall it's good. And I look forward to the next 4 weeks of training and also the Cyberthlon. Right?
Yes, of course, the Cyberthlon. But first, let us explain why we think this exoskeleton is so special. Because we have 3 unique features which we would like to explain to you. And actually, the first unique feature will be explained by Ruben. So, Ruben, how are you able to control the exoskeleton?
It's specially made for my hand, so it fits perfectly. There are 2 buttons on the exoskeleton. The one I use to select a function, or walking, or sitting, or taking the stairs, and the other one is a trigger, just the same as on your computer at home or something like that. And with that one, I start the function that I want to use. Yeah, so that's a lot better than my own exoskeleton, the function.
And would you like to demonstrate a certain function, for example, sitting?
Yeah, I can do that.
Nathan.
By sitting, yeah.
Wait a second. Here see this on the screen, just the icon which is on the crutch handle.
So now I'm going to select sitting, and then select it, and now I can put my crutches where I need to put them. And then pull the trigger, as they say. And then it's that easy.
Wow, perfect. Absolutely amazing, these exoskeletons. But we have 2 more features, I promised, which will be explained. And therefore, I would like to invite on stage Xander and Tekke from Software and Control and Mechanical. Give them an applause.
Yay.
Okay, thank you, Donald. So what you've just seen on this video was, and in real life actually also, is that the exoskeleton starts walking. But before it can walk, the brain of the exoskeleton needs to know which kind of joint angles it has to send to all the joints. And I will explain some more about that today. So these angles the joints will have to follow is what we call a gate. And we've actually presented one of these gates before. This was during our design presentation. And, well, this gate, we actually quite often refer to it as a T-Rex gate, by the way it's pounding its feet in the ground. So it doesn't look so friendly, so we didn't want Ruben to walk like this. So we decided we had to improve on this. But the question was, how are we going to do this? So what we did was come up with several different ideas to generate a gate for our exoskeleton. The first idea we had was really simple. It was using data from research on the human gait and copy this into the March 2. However, there's one big problem with this, and that's that the human body allows for much more movement than our exoskeleton does. So therefore, we can't simply use a human gait and use it in the March 2. No, we need to design a gate specifically for our exoskeleton. So then we came up with our second idea, and that idea was to let someone from our team have a walk with our exoskeleton. And while walking, the March 2 can record all the joint angles and then we have a gait. However, there's also one big problem with this, and that's that when we have this gait, it's really difficult to modify it. So during trainings, we won't be able to change this gait anymore. And we really wanted to be able to do this. So we also didn't go for this option. No, we went for our third option, and that's building an application ourselves. An application in which we can design our own gates and also easily adjust them once we've generated them. So once we had this concept chosen, we started building it, as you can see our software engineer doing over here. Well, while we're working on the software, we noticed that there's a really big challenge we had to face while writing this application. And that's that we have several different disciplines which we have to combine in this application. On the one hand, we need to have knowledge about software and mathematical equations to generate this gate. But on the other hand, we also need to know things about the human body, its joints, and also its walking patterns to be able to generate gates. So to solve this, we decided to hide all the complex software and math underneath a graphical user interface, which can be used to generate the gates. So no math or software knowledge is required to generate any of our walking patterns. So we put a lot of hours of work into it, and after that, it was finally finished. And this is how it looks like. And I will now briefly explain how it works. What you can now see highlighted in red is what we call the input section. This is the most important section of our application because this is where we are going to generate our walking patterns. Over here we can input the different joint angles, so the angle of the hip and the knee. If you look a bit more to the middle of the gate generator, you can see different graphs. On the y-axis or the vertical axis of the graphs, you can see the joint angles, and on the x-axis, let me say that again. On the x-axis, you can see the time. You can also see several different dots. These dots we can move around to generate a gate for the March 2. So let's get started. Well, first, to generate a gate, what we need is a hip joint moving forwards and backwards. And if we make an animation out of that, you can see a first result. However, when we move our leg forwards, we also flex our knees to lift our feet from the ground. So you see me adding that right now, and if we make another animation, we already have a walking exoskeleton. So that's how simple it is to generate a gate with this application. However, what I like most is that we can also really easily adjust these gates once we've generated them. So let's say, for example, this morning, while rehearsing this presentation, Ruben would have said that he wanted to look a bit cooler while walking over here up to the stage. Then
More cooler?
A bit more cooler.
Even more?
Yeah, even more cooler. We can do that, Ruben. We can do that for you. Then we load our previous gate and change some more dots, as you can see me doing over here for the hip joint. And then we make an animation. You have Ruben doing a moonwalk. Well, isn't that cooler, Ruben?
Yeah.
Okay, this is of course a joke, but we've actually used it quite often during trainings to modify small things which didn't seem right while Ruben was walking in it. And this has saved us a lot of time. Maybe even in the future we can use this application on a mobile phone so everybody can easily modify the gait of his or her exoskeleton themselves from your mobile device. So right now I've explained a lot about the gate generator, but the gates are now still in the software world and we want to bring them alive, of course. And this is what Xander will explain right now.
All right, thank you, Tekke, for explaining how the gate generator works. And as you said, the gate is now in the main computer or the brain of the exoskeleton. And we actually want to translate that to the movement of Ruben's legs. And that's why we used the joints, the actuated hip and knee of the exoskeleton. We started this year and we wanted to design our completely own new joint. It had to be able to deliver enough force to walk up the stairs, but we don't just want to attach a giant electromotor to Ruben's legs. We needed some form of transmission, which is like the gear on your bicycle, which makes it easier for you to pedal. We also needed a lot of sensors, because we need to know at every moment where is the exoskeleton so the gate can be played from the main computer. So I, as a mechanical engineer, wasn't just solving a mechanical problem. We had to take electronics into account, and control, and even aesthetics. We held a lot of different meetings about all these interfaces, and I can remember Raphael, our chief engineer, saying, "Verdorie, this might actually be difficult." We started the design by trying out all different concepts and configurations. Which part goes where, and how do we attach those parts together? We came up with a lot of different ideas, and in the end we chose the bottom one. After almost a year of designing, we were really proud when this picture was transformed into this. It looks great, doesn't it? In these months where we went from the concept to this actual design, it became even more apparent how multidisciplinary this project is. We needed an electromotor which had to be able to deliver enough force for Ruben to walk. But high forces also meant high current in the electrical system, and the battery had to be adapted to that. Also, all the sensors needed a very high precision. This precision also added complexity to this design. Sorry. And when we finished this design, we thought we were finished. But we spent 3 more weeks finalizing this design, checking every detail, and putting it on technical drawings. This was really important because when all the parts came in and we started assembling, everything fit like clockwork. And in the end, the joint was strong enough for Ruben to walk, and I can say it is even stronger than Thomas, our strongest team member. I am really proud with this result, and if you ask me, I would even say, all right. I'm really proud with this result, and if you ask me, I would even say we did a really good job on the aesthetics in the end. So, we've seen how Ruben controls the exoskeleton using his input device, then how the main computer of the exoskeleton can play the gate, which is made on the gate generator, and in the end, it will result in the joints moving Ruben's legs. These are three features we wanted to highlight today, because these 3 features are what together they are able to make Ruben stand here on stage with us today. And that is something we really want to highlight because we're really proud of that. Thank you.
Yes, thank you, Ruben, Xander, and Tekke for explaining these extra features. But for now, I will let us look at the future a bit, because we set ourselves to compete in the Cyberthlon experience, which is from now on 33 more days left. So at that point, we should be able to do all 4 obstacles of the competition. And from Monday on, our students from our team will have a double function, because the academic year will start next week. And they will become full-time students again, but with a double life as a Project March engineer. And although we are very happy that we already walked today with Ruben, we still have to do a lot of optimizations. We have to adapt the gate a bit, train the other obstacles, which will cost us a lot of time during the month of September. But also, let us look a little bit extra further in the future, then we come to another point, because I'm also happy to tell you that there is already a 3rd team of Project March engineers has started. This is the new team of Project March, and they started 3 weeks ago with 18 full-timers. 18, that's a lot. They will continue developing the exoskeleton and even increase the technology behind these awesome machines, so that our vision becomes more and more in reality in the upcoming few years. Because We want to give back full mobility to paraplegics to let them participate in daily life activities. And if you watch this photo, this was the team who built the exoskeleton. Because today we're here for the second team, the second march, the exoskeleton, which is Ruben wearing at the moment. Right after we took another picture of this, I would like to invite you all to go downstairs, and I could imagine that you will have a lot of questions for our team members, but also for the new team members to hear about their plans for upcoming year. But let us talk about this picture. Let's see. I can see Ruben sitting down in his wheelchair. Today, I would like to make another picture. I would like to improve this picture while Ruben is standing in our exoskeleton in the March 2. So, therefore, I would like to invite the second team of Project March on stage and to make a new picture.
Ja. Ja, heb ik al gedaan. Oké, 3, 2, 1.
Right, should we just, can you walk in the middle?
Ja.
Let's not make it too easy for him.
Ja. Oké.
Perfect. Right, we are ready for the picture. Love and wave. And of course, we also want to thank our sponsors again for supporting us during this year, because without them, this reveal wouldn't happening today. So let's do this picture one more time. All right. The sponsors are not so... all right. One more time then. Right, thank you all for being here.
Ja, is goed.
Right, I suggest you all go downstairs now and have a drink, and you can all talk to our team members because they will enthusiastically answer all your
Ja, ging
questions.
best goed.
And Ruben is doing okay over here, so that is all fine.
Okay.
If you want to see the last moments of the presentation, that of course.
Ik kon die truck niet naar achter zetten. Juist. Oh ja. Eerst zo en dan zo. Ik kan mij het verrekken, joh. Oh. Hij doet het nou wel. Ja. We moeten het 's ochtends gewoon niet meer doen.